Good morning, guys, and welcome again. Now, as we said last week, Matlab is a matrix laboratory, and that's why we started a review on matrices. So, in fact, we went over their types, we went over their operations, and we learned how to do the multiplication using the multiplication between matrices, and it's a very important operation because we'll be using it in MATLAB later on. And we stopped here, and I asked you to exercise the operations by doing the exercises from 1 till 12. Now, in this video, we will start a new important part, which is called simultaneous equations. We all know, guys, how we can solve, let's say, 2 equations with 2 unknowns, or 3 equations with 3 unknowns. And in some cases, we can solve 4 equations with 4 unknowns. Now, when the number of equations increases and the number of unknowns increases, we should use a software or a programming tool or an advanced calculator to solve such system. And this is what we will be doing on MATLAB. But first of all, I have a question. If I need to solve simultaneous equations of let's say, m number of equations and n number of unknowns, what should be the first ever condition? The first condition, guys, should be that the number of equations is equal to the number of unknowns. If the number of equations is not equal to the number of unknowns, I can't solve the system. So that's why the first condition ever is to have the same number of equations and unknowns. So if, let's say, I only have 2 equations, I can only solve for 2 unknowns. And this is the first condition ever. Now, guys, I want to solve this simple system of 2 equations, 2 unknowns. My unknowns are x1 and x2, and I only have 2 equations, which means I can solve for this system. Guys, I want you to put on your mind the first condition, which is that the number of equations should be equal to the number of unknowns, because I will relate this condition into the type of matrices. So basically, guys, I have this equation, these 2 equations, and I need to solve it. So what should I do? Basically, you can, for example, multiply the second equation by minus 3 over 2, and then sum these 2 equations together. You can find x2, and then you can find x1. Let's do it. Okay, so I'm gonna multiply the second equation by minus 3 over 2. So basically this equation will be what? If I multiply 2 by minus 3 over 2, this will be minus 3x1 minus 6x2. And this should be equal to what? To minus 3. So now this is my second equation, basically. So this is my second equation, and what I'm gonna do is to sum these 2 equations. So if I sum them together, of course, 3x1 will cancel with minus 3x1. I will have only minus x2 is equal to what? To 5 minus 3, which is 2, and this means that x2 is equal to minus 2. So this is basically my first unknown, x2. Now, if I know x2, I can find x1 from one of these 2 equations, either the first one or the second one. You only have to substitute x2 by minus 2. So if this is, let's say, in the second equation, it is much easier. So if this is minus 2, okay, so I'm gonna have 2x1 minus 8 is equal to 2, which means 2x1 is equal to 10, and this means that x1 is equal to 5. So basically, this is my second unknown. So this is how you can solve it by hand. Now, what if I want to solve this system by using the matrices? In fact, guys, I can convert this system into a matrix times another matrix is equal to another constant matrix. So let's see how. What I'm gonna do, guys, I'm gonna take the coefficients of the first row, put it in the first row of this matrix, the coefficient of the second equation and put it in the second row of this matrix, and then I should put here times a column vector that is the column of all the unknowns, which is here only x1 and x2, and then equal to this column vector, which is the constant after the equal sign 5, 2. Now, guys, remember how we did the multiplication? You can verify your answer. Here, because in fact, if I'm gonna do this matrix times this column vector matrix, now this matrix, what is the size of this matrix? It is basically 2 times 2. Now, what is the size of this matrix? It is basically 2 times 1. Can I do the multiplication? Yes, of course, because I have the same internal dimension. And what should be the answer? It should be 2 times 1, which is basically this constant matrix, which means, guys, I can do the multiplication. So if I want to do the multiplication, it is what? It is 3x1 plus 5x2. This is the first equation, and this should be equal to 5. And then 2x1 plus 4x2, and this should be equal to 2. And then I can get back to this system of equations. So basically, guys, if I do the multiplication of the first two matrices, this should be a 2 by 1, 3x1 plus 5x2, and then the second row first term, which is this, which is the only term, is 2x1 plus 4x2. And I know that this multiplication should give me the constant matrix, which is what? 5, 2. And from the operations, guys, I know that if this matrix is equal to this matrix, then each term is equal to its corresponding term, which means 3x1 plus 5x2 is equal to 5, and 2x1 plus 4x2 is equal to 2, so that I can get back to the system of equations. And this means, guys, that this system here, or this equation, this matrix equation here, describes well the system of simultaneous equation here. Okay, so I can do now the implication. All right. Now, how to find x1, x2 using this matrix equation? I know, guys, that this system of two equations is well described by this matrix equation. And I know that this matrix equation could be represented by this equation: AX is equal to B, where A is what? A includes the coefficients of these two equations. Now, what is the size of this A? Basically, guys, the size of A is here, in this case, 2 rows, 2 columns. Now, the 2 rows are coming from the number of equations, which means, guys, the number of rows of A is equal to the number of equations. What else? The number of columns of A are coming from where? They are coming from the number of unknowns. So since I only have two unknowns here, I only have two columns. If I have a second coefficient here plus a 3x3, I should have a third column. So basically, guys, the number of columns of A is equal to the number of unknowns. And I know, guys, that in order to solve a system of simultaneous equation, the first condition is that the number of unknowns is equal to the number of equations, which means, guys, that the number of rows of A should be equal to the number of columns of A, because the number of equations should be equal to the number of unknowns. So if I wanna represent the system of simultaneous equation using an equation matrix, A will be a square matrix. And this is why A here is 2 by 2, two equations, two unknowns. So basically, this will give me that A is square. Okay. Now, guys, put on your mind that A should be square because we will be also using it in finding X. So how to find X? I know that AX is equal to B and that AX and B are matrices. How can I find X? If I multiply both terms by A minus 1, so now A minus 1 times A times X is equal to A minus 1 times B. I can do this because I will not change anything in the equation. I multiplied both terms by A minus 1, or I multiplied both sides of the equal sign by A minus 1. Now I know that A minus 1 times A is what? It is the identity matrix I. And I know that I times X is basically X. So I times X, which is X, is equal to A minus 1 B. And this means, guys, that X is equal to A minus 1 times B. And this is how you can find the unknown X. So basically, X should be equal to the inverse of A times B. Now, how can I relate this one with this condition? Let's recap, guys. I know that I cannot solve a system of equations unless the number of equations is equal to the number of unknowns. Now, this condition urged me to have a square A because if number of equations is equal to the number of unknowns, then A should be square. Now, if A is square, I can do its inverse. Basically, guys, if A is not square, there is no inverse for A. And this is how they are related. So basically, guys, if the number of equations is equal to the number of unknowns, then this means that A is squared. Now, if A is squared, I can do the inverse. Now, if I can do the inverse, I can find X, which is the matrix of unknowns. So guys, you can see that how they are all related. I cannot find X by hand if the number of equations is not equal to the number of unknowns. And here, I cannot find X by the matrix equation if A is not squared, which means if the number of rows is not equal to the number of columns, which means if the number of equations is not equal to the number of unknowns. So this is how you can find X.